Now another thing, so that's phosphorylation. Again, just a little introduction to energy. When you lose ATP, when a person consumes methanol, headache, tremendous headache, and this takes a while. There's no initial reaction because it takes a while for the formaldehyde to modify the protein and for the signal to be sent out for the macrophages to come in. Okay, so we're talking 18 hours or so. What about the actual modification of the protein, the myelin basic protein? There is an amino acid. Now this is going to look technical because I want scientists to hear this. If you have a hard time understanding this, I'll be glad to explain it to you individually. But basically, there's a protein is made up of a bunch of amino acids. Myelin basic protein is made up of amino acids. The most important amino acid for you guys is arginine. Because arginine, it's a formaldehyde capture, a carrier, and a generator molecule. They function as a role of biological activity, and it's methylated. What's that saying? It's just saying that arginine in nature has very low number of formaldehyde molecules attached to it, but it's the amino acid that formaldehyde likes the most. And so if there is formaldehyde, it will migrate to that arginine. There's a lot of arginine in myelin basic protein. So how do I prove that a brain has been attacked by methanol? Well, I have to prove that it's turned into formaldehyde and that formaldehyde has done something. Well, the place to look is arginine. So that's really important. Now, for years, we couldn't do anything about it because there was no way we could tell how much arginine had been modified by formaldehyde. Well, then finally they discovered a method, a very sensitive method, very expensive method, where they can take a protein, like myelin basic protein, and throw it through this machine that shatters it, and they can count all the pieces, and they can tell you. Okay. And this is what I was waiting for, because I wanted to be able to prove that formaldehyde had been in the brain. Now, phosphorylation, I mentioned phosphorylation because it's another thing you could look at when you're looking at a protein, because it can be phosphorylated as well. Okay, so this is it. This is the proof. This article, any medical person, if you take this article to your doctor, you won't know what it talks, anything about what it's about probably, but it doesn't really matter because this is the proof. This is the proof. An important role, this is multiple sclerosis, an important role, post-transitional modifications of myelin basic protein in pathogenesis. English? Okay. What happens to the protein in your brain as the disease carries forward? Okay. In other words, what are the changes in the protein, the myelin basic protein? And they did that work. And this is 2003. I want to tell you how important this is and just show you how beautifully the work was done. Okay. So what they did, and this is easy for you to visualize, I think, they only picked people that had died of accidents, car accidents or something like that. Okay. They took an equal number, they took a sample of people who had multiple sclerosis and a sample of people that never had multiple sclerosis. Then they went into both brains and they sampled tissue, not in the plaque itself, because that's too far gone. The myelin's gone, there's nothing to look at. But tissue just outside of where the plaque was. Tissue that's going to be plaque eventually. And they took exactly the same sample from a normal person's brain, and they just wanted to see the difference. They used this brand new technique. What's the difference between these two tissues? And just show normals were age matched with MS samples. Only white matter from autopsies carried out 8 to 10 hours post-mortem were used. None of the samples had any evidence of additional neurological disease. So they did a great job. Okay, what did they find? We found that mono and dimethylated arginine 107 was increased in MS samples. What that means is that in MS samples, the methylation, that's monomethylation and dimethylation. So in other words, an arginine molecule had been attacked by one formaldehyde or two formaldehydes, and it stuck, therefore modifying it, increased in MS samples. Well, that's what I would look for. What does that show? It shows that formaldehyde is the only thing that can do that. So somehow this has been modified by formaldehyde. The changes observed in human brain were probably related to pathogenesis of myelination, of demyelination. We found another thing they found, decreased phosphorylation. What decreases phosphorylation? Formaldehyde. That's it. So the two changes that occurred in these brains, done by this exquisite study, in contrast to methylation and phosphorylation, was dramatically reduced in the MS samples. Again, the same study. And here's what the bottom line was. This shook me up. Although we do not have any explanation for this state of hypophosphorylation at this time, studies in Alzheimer's disease demonstrated that uncoupling of mitochondrial oxidation, that's what they call it when you reduce phosphorylation, results in decreased amounts of ATP activity, of activated phosphatases, blah, 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 blah. In other words, not only did they discover that this was happening in the MS brain, it was happening in the Alzheimer brain too. And there's no other explanation. These poor guys didn't know anything about formaldehyde. They don't know about methanol. What they found doing this study was exactly the changes that would be caused by formaldehyde in the brain. Nobody knows any way to get formaldehyde in the brain except by methyl alcohol. So there can be no objection to this. I'm not telling you I think, maybe it's a possibility. I'm saying, look.
It's fake.
Yeah, that's it. The work's been done. I don't think any more work has to be done. This is 100 times better than these drug companies have come up with their anti-macrophage war. Jeepers creepers, So if any of you were really hard scientists and could understand the implication of this, you'd be stunned. I was stunned. So this is it. So I just want to encourage you to try this. It can't hurt you. It's going to save you money, probably. And basically, it's the only cause for multiple sclerosis that is credible. I'm not saying that because I came up with it. Doesn't matter. I stumbled on it. Mistake. I was studying something else. So you see what I mean?
The thing is,